Welcome. In today's video, we're going to talk about complex numbers in polar form. So the first task we have got here is to plot the complex number and find its absolute value. So these are few steps that we will be using to solve these kind of questions. So a complex number is represented by the point or by vectors from origin to the point. X-axis becomes the real axis and y-axis becomes the imaginary axis. Remember that we are talking about complex numbers, so we are going to have something that is imaginary. Absolute value can be found by the equation square root of a squared plus b squared when given in the format a plus bi. So whenever you have this absolute value equation, you can use this to find the absolute value, or you can use that to find the total distance of the vector by this formula. So here are a few practice examples. Plot the complex number and find its absolute value. Now, if you remember from the previous slide, complex number is represented by the point. So we need to create a point somewhere that will represent this complex number. This is 6i. Now, you have to remember that this can also be written in the form of 0, 6. And the reason this can be written in a coordinate axis form is because you can rewrite 6i as 0 plus 6i. It is the same thing. So 0 and 6. So all that we have to do is to plot the point 0 and 6 on our graph. So approximately 0, 6 will be this point on our axis. Alright, let's try number 2. We have negative 2i. Now same steps. We will have 0, negative 2, but you also have to remember that this can be rewritten in another form, which is 0 minus 2y. So 0 and negative 2, where does it lie? Well, it lies over here. Remember that we are going down by 2, so this point should make sense. It's really easy. Alright, next we have got the complex number 7. Well, it's not a complex number, it's a real number. It's at 7. So if you have something that is just at 7, you should realize that this can be rewritten in the form of 7, 0. So you can approximate that this point should lie on the x-axis right before 8. Boom, that's our answer. Alright, number 5 is negative 4 plus 4i. Again, this can be written in the form of negative 4, 4. So how can we plot that point on the graph? Well, we go on the x-axis, this is negative 4, and we go up 4, and boom, that is our point. But we're not done, because we also have to find the absolute value. And I purposely left that part out because I really wanted to do them all together. So remember that absolute value can be found by the formula square root of a squared plus b squared when the equation is in the format a plus bi. So if you look at the examples from the following slides, we can actually apply that equation to find the absolute value. So here we got 6i, and we know the coordinate points, which is 0 and 6. So all that we gotta do is do square root of 0 squared plus 6 squared, which gives us root 36. So the absolute value of 6i is gonna be 6. right? If you go up 6, you should come across your point 0.06. So it is basically the distance from the origin. Number 2, we can use the similar formula. Square root of 0 square plus minus 2 square, which gives us root 4, which is 2. So on the graph, if you go down 2 points, you should come across the point negative 2i. Alright, 2 more. Again, we're going to use the formula a squared plus b squared. A in this case is 7, b is 0. So that is going to give us root 49, which is just 7. So again, if you go to the right 7, you should come across the point 7 on the graph. Last one, negative 4 comma 4. So you take square root of negative 4, you add it to this square of 4, you get root 16 plus 16, which is root 32. Boom, that is our answer. Alright, moving on. So now what we have to do is we have to represent a complex number in the trig form. So in order to convert from rectangular form, which is also known as the complex number form, to the trig form, we need to understand and use 2 different equations. So in this exercise, you will be given questions in the rectangular form, and you would be asked to convert it to the trig form. So how do we do it? Well, we of course use the formula, but we also need to understand 2 things. We need to find the value of r from the equation of complex number, and we also need to use the inverse tan function to find the missing angle, because we will have to plug in the values of r and the missing angle into the equation for trig form, right? The r is equal to z and the angle will be equal to theta. So once you plug the numbers in, you should get your answer. So we're going to try a few examples. And to do this, you need to have a unit circle memorized, or if your school doesn't require you to, you need to have that out so that it's much easier. Alright, so number 13, we got 2 plus 2i. So according to our steps, first we need to find the value of r. So how do you find the value of r? Well, r can be found by the formula square root of a squared plus b squared. So essentially, it's the absolute value of the complex number. So we are going to take the square root of 2 squared and add it to 2 squared. By doing that, we get 4 plus 4, which is root 8, which is equal to 2 root 2. So that is the value of r. Now what we need to do is to find the value of the angle. And to find the value of the angle, we need to use the inverse tan function. So tan inverse is of b over a. So this always goes on the top, and this goes on the bottom. So b is 2, so tan inverse of 2 over 2, which equals tan inverse of 1, now which equals 45. This comes from the unit circle. So what we need to do is we need to find our answer in radians. So 45 degrees equals pi over 4 in radians. So now we can use the formula absolute value of z times cosine theta plus sine theta to find our trig form. So the absolute value of z times cosine theta plus I sine theta. Plug in numbers. Absolute value of z is going to be 2 root 2 times cosine of pi over 4 plus I sine pi over 4. Boom. That's our answer. Number 14, same steps. First we need to find the value of r. So value of r can be found by the equation a squared plus b squared, which is going to equal square root of -1 squared plus root 3 squared, which gives us root 4, which is equal to 2. So the value of r equals 2. And we also need to find the angle. So tan inverse is of b over a. That is going to equal to tan inverse of root 3 over 1. So tan inverse of root 3 equals 240 degrees. And 240 degrees, we need to write that in radians. So 240 degrees also equals 4 pi over 3. And if you're confused how I'm getting 4 pi over 3 or how I got pi over 4 here, then I'm getting those values because I'm using the unit circle. I have it memorized. So anyway, moving on. We need to use the equation to convert from our complex form to our trig form. So the equation is absolute value of z times the cosine theta plus I sine theta. Absolute value is 2. You multiply that by cosine of 4 pi over 3. You add it to I sine 4 pi over 3. And that is my answer. Alright, thank you for watching this video. I will be doing more videos very soon, so please go and check them out. Have a good day.